And this is our Chapter 2 quiz review. And for problem 1, we're to sketch the missing shape in the pattern, which in this case would be the third. So we have the first, the shaded square, and then the shaded square inside the square. And then the fourth one is the turned square with the shading as shown. And so since the first one was totally shaded and the second one was inside a square, so this one will be totally shaded on the outside, the four corners, and then the square on the inside would be the missing shape. So for problem 2, make a conjecture, which means a statement about the product of an even number of negative numbers. So if I take, for example, -2 times -2, it's +4. That's an even number 2. And if I take 4 negatives, -2 times -2 times -2 times -2, that would be +16. That's positive. So the statement I can make is the product of an even number of negative numbers is positive. Okay, now for 3, says give a counterexample that disproves the following statement. The quotient of any two counting numbers, and a counting number is 1, 2, 3, 4, 5 on and to infinity is a counting number. The quotient of any two counting numbers is a counting number. So I'm trying to disprove that. So if I just take 1 divided by 2, it's a fraction, which is not a whole counting number. So that just any simple one counting number divided by another one makes a fraction is not a counting number. So now 4 says state whether the statement is true, false, or not a statement. So 5 parentheses x minus 4 equals 5x minus 25 is false because it should be 5x minus 20. But 6 plus 8 equals 5 plus 9 is true because both sides equal 14. And then for part C, 2x equals 10 is not really a statement because I don't know what x is. And without x being stated, I can't tell whether it's true or false. Now for 5, it says write a statement for each symbolization. Now the upside down A means all, the backwards E means some, this kind of V means or, and the upside down V means and wiggle A means not A or some or not, and wiggle E or not E is no or none. So if the statement P is 3D printers are amazing, and the statement Q is smart TVs are popular, then upside down AQ and some or backwards EP is written out as all smart TVs are popular, that's the upside down A, and some 3D printers are amazing. Now not A, P is some 3D printers are not amazing, and not EQ is no smart TVs are popular. Now for 6, it says use the truth table to show the negation of a disjunction, which is not P or Q, is equivalent to the conjunction of the negations, which is not P and not Q. So first of all, we're just going to review the truth table for OR. So if we have for P and Q, true, 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 false, false, true, false, false, then if one of the P or Q is true, then it's true for an OR. So the first 3 on the top circled are true, and an OR is only false if both are false. Now for the AND truth table, P and Q are false if one of them is false or both is false. So the only way an AND can be true is if both are true, which is the top one, but it's mostly false. The 3 bottom circled ones are false because they're both not true. Now to set up for this one we're trying to show, we set up with P and Q, true, false, true, 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 false, false, true, false, false. and then take the not P, which is false, false, true, true, and the not Q, which is the opposite of Q, false, true, then the OR, which we already went over, was true, 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 false, and then the not of that is false, 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 true. And then looking back at not P and not Q, if I add those together, I see that they're only true on the bottom where true, and the rest of the time they're false. So we can see that the last two columns in the truth table are equal, which is what we were trying to show. So that's saying the negation of a disjunction, the not P or Q, is equal to the conjunction of the negations, the not P and not Q. Now we're given a conditional statement if a circle is a polygon, which is false because a polygon needs segments for sides. Then a heptagon is a polygon, which is true. But the truth table for a conditional is for the true, 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 false, false, true, false, false. Then when the conditional is false, when the conditional if, the first part, the P is false, then it doesn't matter what the conclusion is, and the two circled F's show on the bottom make the statement true. That's just what we assume to be true for a conditional. So with the first if false and the conclusion true, the whole conditional is true. It's shown on the third element, the third entry, false, true, true. Now on 8 it says, state whether the condition is true, then write its converse and combine to make a biconditional. So April showers bring May flowers is true, that's the conditional. If it showers in April, then it brings May flowers. The converse just means to read it backwards. May flowers brings April showers, which is false because that's going back in time. And the biconditional is there are April showers if and only if there are May flowers, which is also false because the converse is false, the backwards is false. And so if either part of it's false, the whole biconditional is false. On problem 9 it says, if I make an 88, then I earn a B. So that's my if P, then Q. Now we want to write the contrapositive, which is not Q. If not Q, then not P. So if I don't earn a B backwards, then I don't make an 88. So it's backwards and opposite, or not. And then the equivalent disjunction is not P or Q. So that's if I don't make an 88 or I earn a B. And then problem 10 is, if a cylinder has a polygon as a base, then it is a prism. So that's my if P, then Q. Then the next statement is this cylinder has a polygon for a base, which is just restating P. And then the conclusion is this cylinder is a prism, which is restating Q. And this type of deductive reasoning is called modus ponens. Now for problem 11, we have the premise all triangles are polygons, which we can represent as T if T then P. And the second premise is all triangles are curves if T then C, which are both true. Then the conclusion is all polygons are curves if P then C. But the premises don't connect with the conclusion, and this is an example of invalid reasoning and is therefore an unsound argument. Now for problem 12, the last problem in the quiz, premise 1 is if M is in the midpoint of segment AB, then AM equals MB. Premise 2, M is not a midpoint of AB. Conclusion, AM is not equal to MB. Now notice this follows the premise 1, if P then Q, then premise 2 is not P, not the if is put in a not form, the opposite, and the conclusion is not Q. And this is not true because as I show over here, if I angle AM and MB but still keep them equal, they can be equal but not on a line. So this is an example of the fallacy of the inverse, because just because you make an inverse, it's not necessarily true as is shown here. And this concludes the review for the quiz.